This is a star, a giant one, and these are planets, either a gas giant or rocky one as our Earth. The universe, as we know of, is full of these celestial objects. If we ask ourselves, is there something between them? Are there some supermassive gas giants, or even little stars? Firstly, let's start by quickly recapping what stars and planets are and how they form. Stars form when interstellar gas in nebulae contracts due to gravity, increasing pressure and temperature. Nebulae break into protostellar disks, and if one captures enough matter, which is over 0.08% of the Sun's mass, or simply 80 times Jupiter mass, thermonuclear reactions occur, creating a star that can shine for billions of years. As for planets, after stars form, remaining gas and dust form a rotating protoplanetary disk. Rocky particles collide, forming larger masses through gravity, resulting in solid inner planets. Meanwhile, gas giants like Jupiter form when the remaining gas and dust in a protoplanetary disk gravitationally accumulates around a solid core, gradually building up a massive atmosphere. For planets, there is a speculative rule that they don't exceed 13 times the mass of Jupiter. Now that you are equipped with essential knowledge to move forward, you might have noticed that the existential range for these stellar objects was mentioned. They are bigger than planets which have upper limit of 13 Jupiter's masses. The upper limit for these objects is when they have lower mass than that of 80 times Jupiter's, or 0.08% of Sun mass. Reason for that is because they simply lack the energy needed to squeeze hydrogen together hard enough to generate fusion because of their mass. Although some fusion happens even in these objects, with the presence of lithium in their atmospheres, which normal stars lack. Lithium, much like hydrogen, can undergo fusion reactions. However, regular stars exhaust their lithium supply in their early stages, offering a unique test for identifying these failed stars. Additionally, it's worth noting that objects with a mass exceeding about 13 times that of Jupiter can also fuse deuterium, an atom closely related to hydrogen, but featuring a proton and a neutron in its nucleus. This makes them different, both from planets and stars. For being a star, they would need to fuse hydrogen. For being a planet, they can't be that massive, and there just shouldn't be any fusion happening. What would such an object look like? Perhaps it would take shape like a star, collapsing from a gas cloud, but instead of igniting and becoming a star, it would simply pause there, cooling. Initially, it might radiate intense heat due to the physical forces that created it, but it would be unable to sustain that heat. Like a campfire, it would slowly radiate its warmth into the surrounding space. After a few billion years, it would be cold, black, and almost invisible to normal sight. Now we can go back to naming these objects. Black dwarfs? Well, not these. Black dwarfs were in a play, but they've already been given to another stellar objects. So, the name was chosen to be brown dwarfs. The name suggests they are brown, but that's not entirely the case. Their color is determined by their temperature, and brown dwarfs can actually be classified into 3 different spectral types on the HR diagram, each having a distinct hue, L, T, and Y. Among them, L-class dwarfs are the hottest and consist mainly of plasma, resembling the color of red dwarfs. T-class dwarfs, slightly cooler than L-class, possess a combination of plasma and gas, and appear magenta in hue. Finally, Y-class dwarfs, the coolest of the 3, are primarily composed of gas, assuming they form like stars. These would be extremely faint, only visible in infrared light as they reach the end of their cooling process and take on a nearly black appearance. Brown dwarfs were theorized in the 1960s, with the first one discovered in 1995, called Tater 1. Found in the Taurus constellation, Tater 1 sits roughly 400 light-years away, with a scorching surface temperature of 2700 Kelvin and a mass 55 times that of Jupiter. For comparison, the biggest brown dwarf found, also perhaps with the longest name, has a mass of 90 times that of Jupiter and is still a subject for observations. Do you believe brown dwarfs possess the capability to have planets orbiting within their habitable zones? Maybe you are not far from truth. Some have speculated whether it is possible for a planet orbiting a brown dwarf to have liquid water on its surface for a period sufficiently long enough to host the development of Earth-type life. By using computer models, scientists found out that the habitable zones around brown dwarfs are extremely narrow, which makes habitable planets around brown dwarfs unlikely. Even worse, the habitable zones will shrink down even smaller and faster due to the cooling of brown dwarfs. But it doesn't just end there. A planet needs to have an extremely low orbit eccentricity to avoid strong tidal forces, which leads to greenhouse effect that heats up the planet. If you want to know more about giant and possibly habitable exoplanets, then go check out this video.